We're going to start off reviewing discrete domain and range that we worked on yesterday. Here we have a graph. Remember, we talked about discrete is going to be a scatter plot and it's going to have dots. Our domain, if you recall, is going to be all of our x values, and our range is going to be all of our y values. We talked about several ways that you could do this. We said one way was to write the coordinate for each point next to it, or you could go ahead and you could make a table if you preferred. So whichever method you like would be the one you should stick with. If you are unsure of how to write a coordinate, remember we always go across from the origin and then up or down. So this is what it would look like if you made if you labeled the coordinates, and if you made a table, it would look like this. So again, whichever method you prefer is going to be up to you. So we can see if you're looking at a table, here is our domain, our x values. So if we're going to write those, remember they are individual numbers. It is countable. We always write in order from least to greatest. 2, 5. And then the range is going to be all of your y values, again, in order from least to greatest. So this one you kind of have to look at. Now we did talk about we are not going to write any repeat numbers. I have 2 -3s, but I am only going to write that one time. All right. Is it a function? So remember, if it is a function, we have no repeat x's. So we are looking at our list right here of our domain, and they are all different. So yes, it is a function. We also talked about function notation this week. So f of -3, remember we talked about f of x. So this is saying where x is -3. So if I come over here to my graph, here's where x is -3, but if you look, there are no dots. So in this case, we do not have a y. So this is what we call undefined, right? There is not one. To review our synonyms that we talked about in class earlier this week, we can write x is going to be our domain. It is our independent variable, and it is our input. And y is our range, our dependent variable, and our output. So when we look here, our domain is going to be the set of all of our x values. And today we're going to be looking at using inequalities on continuous graphs. So this is going to be a little bit different. We are going to have inequalities. It is always going to follow our pattern. Domain is always left to right because these are our x's. Okay, we always, just like when we list them, we're going least to greatest or low to high. I do want you to notice that these are always less than. They're always going to be less thans. On occasion, if we have our closed circle, we've talked about those when we did inequalities. So our closed circle is going to have the or equal to. We may need to add this extra line in those cases. And then our range is going to be bottom to top. And again, that is still low to high. Okay. We're using those less thans, and it is going to be an open circle if we have an just is going to be just a less than, excuse me, if we have an open circle. Okay? So when we talk about what this means, the domain and range are going to be all real numbers greater than a number and less than a number, which is why we have our format like this, okay? Where you have x is less than some x or y is less than some bigger number, and if we read it backwards, x is greater than or y is greater than some smaller number. So we can do a couple of things to help us remember this. If we have a less than or a greater than, it's going to be an open circle with our arrow. Sometimes we have an arrow on there so we won't have a line. Less than and greater than is going to be a closed circle. There will be no arrows. Okay. If we look, so let's actually look at an example, and we're going to use the window kind of format. So I'm going to take my highlighter, or you could take your pencil or a colored pen, and I'm going to put a window around my graph. So I'm making a box here. Okay. Keep in mind our pattern, something is less than x for our domain is less than something. So when I talk about that, remember we are going left to right. So my leftmost number is a -6. My rightmost number is +8. And then I can go back and I can look at, I do happen to have a closed circle on the -6, so I have to put the or equal to. I have an open circle on my 8, so I'm going to leave my less than. My range is the same pattern, guys. It's the same pattern every time. And this one is going to be bottom to top, still least to greatest. So my lowest y number is -3, and I can see that it goes with the open circle, so I'm going to leave this a less than. My highest, or my top y number, is +4, and it is with the closed circle, so I'm going to have to put my line. Guys, it's going to be that same pattern every single time. Something less than x or y, less than something. So if we continue, here's another one. This one happens to have a word problem with it. Students leaving drive back from college for the fall semester. The graph shows the distance from the college as a linear function of x, the number of hours driven. What is the domain and range? So again, I'm going to go ahead and I'm going to draw my window. I apologize. My lines did not transfer very well. Hopefully they look better on your paper. So if we're talking about the domain, right? Something is less than x is less than something. And this is an x because we are talking about domain. Now, there are no circles on here, but you know that you have to start, right? 0 hours driven, and then when you get where you're going. So these are going to be implied closed circles. I'm going to go ahead and put my line. So remember, left to right on domain. My leftmost number is 0. My rightmost number we have, this is broken into quarters, so 5:15, 5.5 hours, so 5.5. And again, our range, the bottom to the top. And again, these are closed circles, so we're going to go ahead and put our line. So my bottommost number for distance from the college is 0. And my topmost number, again, this is got 4s. So in between 300 and 250 will be 275. So again, you're looking only at your top and your bottom. If we wanted to, we could put a coordinate here, 0 to 75. We could put 5.50. All right, one more example, two more examples. And this one has arrows. So let's talk about what those arrows mean. So we are not going to be able to draw a box here. These arrows mean that we are going to continue on infinitely in both directions. So I don't have a leftmost. If I did, I could say maybe negative infinity to positive infinity. Infinity is kind of that sideways 8. And I could do the same thing for range, okay? My bottom is just going to keep going down, down, down. So negative infinity and up, up, up to positive infinity. Now, we actually have a term for that in algebra. This is called all real numbers. And the symbol for it is a double-lined R. So we won't necessarily see negative infinity to positive infinity, but we will see all real numbers. And that does mean negative infinity to positive infinity. This last one, you're going to need to use your calculator to graph it. We saw a little bit of an example like this. No, I guess we did not yet. You will have one like this on your practice, though. So remember, f of x is the same as y. When you graph this, there is no x, there is no slope. It is going to be a line that goes through the y-axis at 13. And it is going to continue in both directions. So left to right, our domain would be negative infinity to positive infinity. Or, we just learned, we can write all real numbers. You can either write it out or you can use a symbol. Now, the range is a little different because every dot on this line, if I made a table, right, 1, 2, 3, 4, so on, every y value is going to be 13. So the range, because all of my y's are 13, is y equals 13. So you will have a couple of those on your practice today where you're going to need to use your graphing calculator and see what that graph looks like so that you can find the high, the low, the left, and the right. Have a great evening.